Imagine a world where your smartphone battery lasts for months on a single charge, where trains fly over tracks at 500 miles per hour, and where the word energy crisis no longer exists. This sounds like a dream, but in the world's most secretive labs, scientists are chasing a material called a room-temperature superconductor. It's the holy grail of modern physics. A secret that could make electricity move with zero resistance and zero heat. I'm Techy Jutt, and today we are uncovering the technology that will trigger the greatest industrial revolution in human history. We are talking about the end of wasted power and the beginning of a truly futuristic civilization. Let's see what they're hiding from us. The biggest problem with our current technology is resistance. Whenever electricity flows through a wire, it hits resistance, which creates heat and wastes energy. This is why your laptop gets hot and why we lose up to 15% of all electricity during transmission from power plants. A superconductor is a material that allows electricity to flow with absolutely zero resistance. But for decades, this only worked at temperatures colder than deep space. The secret breakthrough everyone is chasing now is a material that can do this at room temperature, if we find it. We can transport electricity from a solar farm in the desert to a city thousands of miles away without losing a single drop of power. This technology would completely reinvent how we move. Right now, maglev trains use superconductors, but they require massive cooling systems that make them incredibly expensive. With room temperature superconductors, we could build floating tracks everywhere. Your car, your bike, and even your city's public transport could use magnetic levitation to glide over the ground with zero friction. This would make transportation incredibly fast and almost silent. The secret isn't just about speed, it's about efficiency. Without friction or air resistance and hyperloop tubes, we could travel between countries in minutes instead of hours, using only a fraction of the energy we use today. For the Techy Jutt community, the most exciting part is the battery revolution. Current lithium-ion batteries are slow to charge and lose power over time. But with superconducting materials, we could create supercapacitors that store energy indefinitely. Imagine charging your phone or your electric car in just 3 seconds, and that charge lasting for weeks. This is because the energy would just keep looping inside the superconductor without ever burning off as heat. This would solve the biggest hurdle for electric vehicles and renewable energy, making fossil fuels completely obsolete almost overnight. The secret of desktop quantum computing also lies in this material. Right now, quantum computers like those at Google and IBM need to be kept in giant refrigerators to work. A room temperature superconductor would allow us to shrink that power into a device the size of your smartphone. This would bring the power of a supercomputer into your pocket, allowing for real-time AI processing that is millions of times faster than what we have today. We are talking about a world where your personal device can solve complex global problems or simulate new medicines while you are walking down the street. It's a total shift in human processing power. But there is a dark, secret side to this discovery: the energy war. Right now, the global economy is built on oil, gas, and coal. If a room temperature superconductor is discovered and patented by a single company or country, it would wipe out the trillions of dollars invested in traditional energy. This is why there is so much secrecy and controversy around recent claims of discovery, like the LK-99 incident. The race to own the formula for this material is the new gold rush. Governments are pouring billions into secret research because whoever controls this material will essentially control the world. As energy supply for the next century, we also have to talk about fusion energy. We've been trying to create a sun on Earth through nuclear fusion for years, but the biggest challenge is containing the massive heat using magnets. Superconductors are the key to these magnets. A room temperature version would make fusion reactors smaller, cheaper, and safer.
Nice.
This would provide the world with infinite clean energy using just a few gallons of seawater as fuel. It would mean the end of poverty and the end of carbon emissions. The secret potential here is so big that it could literally save our planet from the brink of climate collapse, making energy so cheap it's not even worth charging for. As we look toward 2026, the scientific world is on high alert. Every week, new papers are published and secret experiments are conducted to find that perfect atomic structure. When it happens, it won't just be a headline. It will be the day the world changes forever. For the Jutt community, this is a call to look beyond the gadgets and see the materials that power them. We are moving from an age of heat and waste to an age of flow and infinite power. Stay tuned with Techy Jutt as we track the materials that are building our future. The age of the superconductor is almost here, and it's going to be electric.